Hello students, today's class we'll see study of gas laws part 2. Last class we have seen so many laws like say for example we have learned about the Boyle's law, that is P at constant temperature P1 V1 equal to P2 V2, and Charles law at constant pressure B1 by T1 equal to V2 by T2, and gas equation by combining those two laws P1 V1 by T1 equal to P2 V2 by T2. Now today's class we'll see some numericals based only on Boyle's law. So Boyle's law numericals alone we are going to see. See, before going for this certain thing we need conversions there. So volume value 1 liter equal to 1 decimeter cube. Any conversion is needed, make use of this one either in volume or pressure. 1 centimeter cube equal to 1 ml, that is 1000 centimeter cube equal to 1000 ml. So 1 liter will be equal to 1000 centimeter cube, because we are going to make use of this conversion in this problem. Now pressure also, if they have given in centimeter, make use of this value 76 centimeter mercury. Millimeter means 760 millimeter. So atmos value 1 atmos equal to this one. So mostly they will be giving centimeter or millimeter. Now let's see about in this problem. The pressure of a gas having volume 380 liters originally occupying 800 centimeter cube at 76 centimeter pressure, temperature being constant. See, if the word temperature being constant, it is a clue for you that it is Boyle's law formula you are going to apply. Originally occupying means it is initially what is the volume and what is the pressure. So now volume value 1 is given in centimeter cube, the other volume is given as liters. So initial pressure you can take it as 76 centimeter and initial volume as 800 centimeter cube and V2 value as 380 liters. Now this 380 liters I need to convert it into centimeter cube. So 1 liter equal to 1000 centimeter cube. So 380 into 1000, when you multiply you will be getting it as 3840 zeros. That means you will get 3,80,000 centimeter cube. So I have converted this also into centimeter cube. So P2 value I need to calculate. So be careful in writing P1 V1 value, initial pressure and volume, because if you change this one then you will get a wrong answer. So be careful, read the problem twice or thrice, then you will get the thing. Now coming to the formula P1 V1 equal to P2 V2. So now coming to this P2 I am going to calculate. So P1 V1 it will come to the numerator, denominator V2, because when you cross multiply this V2 will come here. So please write this formula carefully there, because for writing formula you will get 1 mark. The given data also you should write it properly there. So this is also must directly, if you substitute in the formula you won't be getting full marks there. So be careful. Conversion also you have to do it, and final answer unit also you have to write it correctly there. So please be careful in writing the given data carries marks, formula carries marks, substitution also carries marks, and final answer with the unit also carries marks. So now I have converted here. Now P1 value is 76 and your V1 value is 800, and now coming to the V2 value I have converted and kept it as, so 4 zeros are there, right? 4 zeros are there, the 0 also is there. Now what we are going to do is cancel this 0 and this 0, and you can, because this goes twice here, the 38 into 2 you will be getting it as, or you can cancel it in 2 tables also. So here you will be getting it as 40, 2 tables, and here 1 9 0 0 0 you will be getting 3 zeros are there. Now again if you go for a calculation here you will be getting say for example here 20, I think 2 it will go easily there, that's what I feel. Okay, now here 9 5 0 0, again 5 tables you can cancel it, you will be getting 4, here 1 9 0 0. So I think this will go how many times? That is 4 times. 4 9s are 36 7. So I think this will go 4, and this is 100, and again you can cancel, this is 2 50 you will be getting, and again 125. So more or less you will be getting the value as 4 by 25 means you will be getting 0.1s, then 25 115 you will get again 15 or how much. So when you divide it by 25, 40, 0.0125, here it's 5, 150, so it will go 6 times, so you are getting it as 150. So directly you would have done the calculation like the 76 into, that is 800 by 38,000, that is 3,80,000. So this 0 you can cancel it, and this will go to 100, then 50. This is 2 tables, so 4 by 20, either by using this way or this way. Anyway, the final answer is 0.16. What is the unit? So unit is going to be centimeter pressure. So this is the value which you are getting it for the first one. So please be careful in substituting the values. Now let's see about say for example the second problem. The pressure of a gas having volume. See, your volume is 1500 centimeter cube, originally occupying 750 cc at 5 atmospheric pressure. So what is the P1 value here? Originally occupy means this will be your initial volume, initial pressure. So P1 equal to 5 atmos, then V1 equal to 750 cc and V2 equal to 1500 cc. You are going to calculate PT. So formula is P1 V1 equal to P2 V2. Then P2 you are going to calculate, right? P1 V1 divided by V2. So substitute the values here. Say for example, so I am going to substitute the values. P1 value is, actually what is your P1 value? 5 atmos, and V1 value is 750. And now divided by 1500. So now you are getting the value as you can simply, it will go to twice here. 5 by 2 means you can divide it and write it as 2.5. And what is the value which you are calculating? Pressure. So you will be getting it as 2.5 atmos. So this is the final value for this problem. So read the problem twice and see that which is P1, V1, and accordingly you calculate it. Now let's see about one more example. A gas occupies a volume of 300 centimeter cube under a pressure of 350 mm mercury. So this is the volume and this is the pressure. So volume is going to be V1. This is the initial volume, initial pressure. Find under what pressure of the gas it occupies a volume of 380 centimeter cube. The temperature during the reaction remains constant. So temperature remains constant means it is understood, it is the Boyle's law there. So calculate it here. P1 value is 350 mm mercury and your V1 value is 300 and your V2 value is say that is 380 centimeter cube. Now you are going to calculate the P2. So using the Boyle's law, P1 V1 equal to P2 V2. So P2 equal to P1 V1 by V2. So now I have to substitute the values. See, your P1 value is 350. And what about your V1 value is 300. Divided by, you will be getting it as say V2 value is 380. So now you can cancel 0, 0. You can simplify this with 2 tables, that is 119 here. So of course anyway you will be getting the value like this, and if you multiply this 150 into 35, you are getting the value as 25 to 7 and 3 is 0, 15, 4. Now 0, 5, 12, 5. So now you have to divide this one. Say for example 5 to 50 divided by this 90. So it will go 2 times here, twice. So 38 you will get. Now 4, 1, 5. Then 7 times I think it will go 133. Then again subtract this one, 1, 2, 0. So around, I think less than this means 6 times it will go. So we'll be getting as 114, remainder 1 5. Okay, now like that it goes. Actually here I am getting it as 60 point, then it will go 3 times. So 3 times means, see again I'll do it here, 60, that is 3 9 27 to 57 it goes, 57, then again 3 0, so it will go once only, 19, and again 1 1 0, so it will go around like a 5 when you take, you will be getting it as 5 9 45 4, I think 95 you are getting, see 5 9 45 4 95, so around like, so like that it goes. So actually when you get a problem like this, like decimal places, at least once after the decimal point, one digit place should be there. So please take it into mind, 1 or 2 after the decimal point, at least one decimal places should be there. See to that. So 3 1 I am getting means, actually here, see here 1, if it is 5 means I have to add it here 1, so I will be getting at 276.3. that is the answer there. So much of what is the value, that is millimeter mercury. So that much value you will get it. So in case instead of this one 276.35 it's given means, suppose I am getting the value like this, I want to correct it to this place. So it is 5 above 5 means I should add one number here. So final value will be 276.4. Like that you have to write it. So corrected to one decimal places means, here see I have 1 here, so I need not add 1 to this 3 there. So final answer 276.3. This is the value which you are getting. So much of millimeter mercury there, this much of millimeter mercury. So that will be the answer here, millimeter mercury. This is the final answer for us. So if you are getting decimal places, see to that 5 and above 5 you have to take into consideration. Now let's see about three more examples. Like say for example, a gas occupies the volume of 1 liter under atmospheric pressure. 1 liter under atmospheric pressure. So when you take this atmospheric pressure term there, you should be very careful here, because I'll tell you later what will be the volume of the same amount of gas under 750 mm mercury at same temperature. See, when you look at this problem, I have volume value here and they have given pressure value. So only 2 datas are given. So what happened to the third data there? So they have given the term under atmospheric pressure. So just now I was telling about atmospheric pressure means, so you have to use of 760 mm mercury. So as in the formula I was telling you, can you see this formula? 760 mm mercury. So this is the value which I am going to substitute there. So now what we are going to do is, see your P1 value we have taken as 760 mm mercury. That is your gas occupies the pressure, at atmospheric pressure, this pressure, and volume is going to be 1 liter. Now what will be your volume? So I have to calculate the volume at the same amount of gas and the pressure is different. Pressure varies there. If there is a change in the pressure and volume only, we are making use of this formula. So 750 mm mercury. So make you V2 I have to calculate. So how you got the 760 mm mercury means, see 1 liter under atmospheric pressure. So I have to make use of standard value, that is 760 mm mercury, because in the problem only 2 datas are given, 750 mm mercury and this liter they have given. So make use of this one and write it. So now P1 V1 equal to P2 V2. So V2 value equal to, I am going to calculate V2, P1 V1 divided by, so your P1 value is going to be 760 and V1 value is 1 divided by, and P2 value 750. So now cancel this. So when you divide this one, that is 75, 76, that is 175, then 1, 0, because it is not divided, so write it as 0. Now one more 0 you add it, Now I'll be getting it as say around ones only, that is 75, then 250, and one more 0 you have added, so it goes, I think 3 5s are 15, 22. So now 25. So like that is goes. So anyway, your value is going to be 1 liter or 1.0 only here, because after the decimal point 1 places, if you calculate, it's okay, fine. So, or you can write it as 1.01 liters also. So both are okay, or 1.0 means you will be getting this value, 1 value. So this is your final value. So this is much of volume. Under this was the variation in the pressure there. Now coming to the next problem, that is at constant temperature gas occupies a volume of 2000 centimeter cube at a pressure of 740 mm mercury. Find at what pressure its volume will be 500 centimeter cube. So 500 centimeter cube means here what we are going to do is, see, your volume value is given as 2000. This is your initial volume, and your pressure value is given as 740. So you are going to calculate the pressure using 500 centimeter cube. So P1 value is 740 and your V1 value is 2000 centimeter cube and your V2 value is 500 centimeter. So you are going to calculate P2. So now you are making use of the formula P1 V1 equal to P2 V2. That is, for example, P2 equal to P1 V1 by V2. Now substitute your P1 value as 740 and your V1 value is 2000 divided by V2 value is 500. So now this goes 4, right? 4 times, and your value is going to be 40. 4 4s are 60, 129. So this many pressure value. So its unit should be mm mercury. This is your final answer. Is it clear for you? Now one more example we'll see. Say see, a weather balloon has a volume. A balloon has a volume of 175 liter. Now, when filled with hydrogen at a pressure of, its volume is about 175 and with the pressure of 1 atmosphere. Calculate the volume of the balloon when it rises to a height of 200 meter where the atmospheric pressure is 0.80 atmosphere. So P1 value is given as 1 atmosphere. That is your P1 value. That was the value which is given the initially. And your volume, initial volume is given as 175 liters. Now your P2 value, see this 200 meter you need not worry, it is mentioning about the height. So this is not required in the data there. So only the pressure and the volume terms we are making use of that. So volume, initial volume is given 175, initial pressure is this much. And what will be your volume when it is atmospheric pressure at 0.80 atmosphere. So both are in atmosphere. See that whatever problem is given, see both the volumes and the pressure are in the same unit. That is main thing. So here it is little, this both the pressure are in atmosphere only. So now P1 equal to 1 atmosphere, V1 equal to 175 liters. Then P2 value is given 0.80. So now V2 I have to calculate. So write the formula as P1 V1 equal to P2 V2, that is V2 value you are going to calculate. So now substitute all the values, that is 1 atmosphere into volume value is 175 divided by 0.80. Now I am getting a decimal value. So to remove the decimal point, you know that you will multiply numerator and denominator by 100. So you will be getting the answer as 17500 divided by 80. That is, you will get 2 zeros there, but 2 decimal places it will go. So cancel this. Divide this 1750 with 8. So divide 1750 with 8. So you know that 16. Now 1 5. Again once only it will go 8. Then 7 0. So how many times it will go? This is 8 times, right? 8 is 64. And again what will happen here? You are getting 60 point or what? Oh, no. Yeah, point you are getting there. 2 decimal places here, no? It has been removed. 1. Is it right, the decimal places which you have given here? I think, yeah, it's correct. And 2 decimal places. One more 0 is added, no? Am I right? One more 0 is added. Yeah. See the calculation here. See 2 zeros here. 3 zeros are there. Okay, I have written 3 zeros. Cancel and 8. See 2 times 16 here. And here 15 once, 8. Then 7 0, 64, then point. And again you will be getting it as 7 times 56. Then 4 0. 5 times it goes, so 40. So I am getting it as the value as you are getting the value 218.75. This is your final value. So this many liters is volume is changes is there. Balloon, it rises to a height where the atmospheric pressure is. So your pressure value is 0.80, means your volume value has been given as 218.75. So do the calculation. So whenever you get a decimal places, you know the calculation. Please be careful in doing this calculations there, because mostly you will be getting double the values. Calculation part will be easy. You are not supposed to use a calculator for numericals. You have to make use of the addition, multiplication. Please be careful in doing the calculations there. Now you have an assignment. You can make a note of this assignment. 3 problems is given. Just I'll read it. See, 50 cc of hydrogen in a closed vessel maintain a pressure of 1400 mm mercury. It is allowed to expand to 125 cc. What would be the pressure? Now the second problem, the pressure of a gas having volume 1000 cc, originally occupying 1500 cc at 720 mm pressure. Then third problem, at a pressure 152 centimeter mercury, a gas X. So we don't know the name of the gas, just X is given there. That means it is not the value. Say it may be any gases. As a volume of 50 cc, at what pressure will the volume be? 30 cc. So your temperature remains constant throughout. So temperature remains constant throughout. So all these 3 numericals are based on Boyle's law. See that whether in the first problem both the units are same, and here also check that both the units are same here. If there is a difference here also cc, and this is also cc, and your answer for this one is going to come in centimeter mercury, and the previous problem also mm mercury you have tried, and this one I think mm only you will get. So pressure value you are going to calculate, here you are going to calculate volume. So you know the formula, make use of the formula, and the answers for this one will be discussed in the Google Meet class. Please work out all this thing, whatever problems is given. Thank you, students.